All right, everybody, so this is the experiment on lab table 1. This is reaction 1. I'm placing a magnesium strip into the fire just to heat it. Notice that when I place it at the base of the fire, nothing happens. That's because there's no air there. If I move it to where air is meeting the fire, all of a sudden the reaction begins. So the magnesium is reacting with one of the elements in the air, and that element is oxygen. So the reactants for this reaction are magnesium and oxygen gas. Two elements, so think about what product could form. All right, guys, this is the experiment on lab station 2. What I'm going to do is I've already placed a magnesium strip into the test tube. I'm going to add some hydrochloric acid. Okay, so you can see that there are bubbles forming. There's a gas being produced. And all I'm doing is lighting a wooden splint. And if I place that splint next to the tube, we get a little explosion. That little explosion is the gas igniting. So think about what gas could be igniting if we're putting hydrochloric acid with magnesium. There it goes again. Let's see if we can get it to light one more time. There it goes. Okay. Okay, this is the reaction on lab station 3. This is lab reaction 3. So what I've done is placed a small amount of ammonium carbonate in a test tube. Now if you look carefully, there's a liquid forming there. So you guys can see the liquid as it forms. Okay, let me just turn off the gas. Okay, so the liquid is forming there. And if I place a test paper, litmus test paper, in the tube, I see that the litmus test paper actually turns blue. And that is due to the formation of a base. That base, I know you can't smell it, is actually going to be ammonia. Okay. There's also a second gas being produced because this is a carbonate. You get liquid water always from a carbonate, and you always get carbon dioxide from a carbonate. Okay. The third product here is that basic gas, ammonia. Okay guys, this is reaction 4 on lab station 4. So in the test tube, I have placed a small amount of calcium carbonate. To the calcium carbonate, I'm going to add hydrochloric acid. Now, as soon as I add the hydrochloric acid, you can see that a gas forms. And if I light a match and hold it to the test tube, the match goes right out. So that indicates carbon dioxide gas is one of the products of this reaction. It's a carbonate, and again, from a carbonate, you always get carbon dioxide gas and water. So if you can see all the liquid that's in there, that's the water that formed during the reaction. There is also a white solid. So you need to think about what that could be, what compound that could be. There's a third compound besides water and carbon dioxide. There's going to be a third compound that forms as a product in this reaction. Okay, everybody, at lab station 5, we actually had both reactions 5 and reaction 6. So I'm going to do reaction 5 first. The first thing I'm going to do is place a small piece of solid zinc in the test tube. So if I'm just placing a small piece of metal in a test tube. To that metal, zinc metal, I'm going to add copper 2 chloride. Okay, so this is reaction 5. I've put zinc metal and copper 2 chloride together. Those are the reactants. We're going to let that sit for a minute and go back and look at it in a minute. Okay, reaction number 6 is also at this table. The first thing I'm going to do is put some copper 2 chloride in this test tube. So again, I'm starting with copper 2 chloride. To that, I'm going to add sodium phosphate. Now notice the formation of a solid during this reaction. So I put together two ionic compounds and I ended up getting a solid as one of my products. Okay, so think about what type of reaction starts off with two ionic compounds, in this case copper 2 chloride and sodium phosphate, and forms a solid product at the end. Okay, that was reaction 6. Let's look back at reaction 5. If we look at it, the metal has actually changed. And I'll hold it up a little bit so you can see it. It's no longer that silvery color. Instead, it has become a dark reddish brown color. That indicates the formation of copper. I know it's kind of hard to see. It's not really focusing very well, but that's actually copper in there. The zinc metal has been replaced by copper. So think about what type of reaction causes one metal to replace another in a compound. Okay? In this case, zinc was replaced by copper. I started off with an element and a compound. Okay, so think about what type of reaction that is. Okay, so at the last lab station 6, we actually have reactions 7 and 8. So I'm going to go ahead and do reaction 7. To one of the test tubes, I am just going to add some sodium hydroxide. Okay, so all that's in there right now is sodium hydroxide. Now I'm going to add a drop of phenolphthalein, which is a pH indicator. That color indicates that this is a basic solution, which is not a surprise. It's sodium hydroxide, contains hydroxide, so it's a base. Okay. Now to that base, sodium hydroxide, I am going to add hydrochloric acid. Notice that the pH indicator is no longer indicating that a base is present. Instead, it's clear, like water. So I put together sodium hydroxide and hydrochloric acid, and it seems to have turned into water as one of the products. There is going to be a second product here, but water is one of the products. So think about what type of reaction that would be if I put together hydrochloric acid and sodium hydroxide and ended up with water and another product. Okay? For the very last reaction, I'm actually just going to do it right here on the table. This is ethyl alcohol. Okay, it's a hydrocarbon. I know it's a little smeared there, but it's C2H5OH. Okay, that's the formula for ethyl alcohol. Notice the presence of carbon and hydrogen. This is a hydrocarbon. So I'm just going to put some of that on the lab table, close the bottle, and move it away. And then excuse me for just a second while I light a match. Okay, so here we go. I'm going to light the match. And notice that a flame starts. So this is a reaction in which a flame is produced. Think about what type of reaction has flames, right? I started with a hydrocarbon. We know that if something burns, that it also has to react with oxygen, so that should be the second reactant. Notice that there's moisture left on the lab table, so water was a product of this reaction. And then the second product should be a gas. There was a gas there. The liquid water was one of the products. Ethyl alcohol and O2 oxygen were the reactants. So think about the type of reaction.